To solve a polynomial equation, we begin by applying the rational root theorem. According to this theorem, any rational root of a polynomial is of the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. In this case, the constant term is -2, with factors positive and -1 and 2, while the leading coefficient is 3, with factors positive and -1 and 3. Dividing these, the possible rational roots are positive and -1, 1/3, 2, and 2/3. We consider both positive and negative values because a polynomial can have roots of either sign. We test each possible root by substituting it into the polynomial to check if it equals 0. Substituting 1 into the polynomial results in 4. Substituting -1 results in 6. Substituting 1/3 results in -22/9. Substituting -1/3 results in a 0. So we found one of the roots. Let's continue to see if there are more. Substituting 2 results in 42. Next, plugging in -2 results in 10. 2/3 results in -2/3. And finally, plugging in -2/3 results in 26/9. Therefore, -1/3 is the only rational root, which means x plus 1/3 is a factor of the polynomial. Now let's find any remaining roots. The fundamental theorem of algebra states that every polynomial of degree n has exactly n roots in the set of complex numbers. Since the polynomial is degree 3, we expect 3 roots total. We can use synthetic division to divide the original polynomial by the binomial factor x plus 1/3. Use just the coefficients of the polynomial and the 0 of the binomial, -1/3. Begin by bringing down the first coefficient, 3. We multiply it by -1/3, which gives -1. Adding this to the second coefficient, 7, we get 6. Then we multiply 6 by -1/3, giving -2. Adding this to the third coefficient, -4, we get -6. Multiplying -6 by -1/3 gives 2. And adding this to the last coefficient, -2, we get 0. This confirms the division is exact. Since we divided a cubic polynomial by a linear factor, it reduces the degree by 1, resulting in a quadratic polynomial. We get 3x squared plus 6x minus 6. Set it equal to 0, and since the quadratic equation has a common factor of 3, we factor it out, giving 3 times x squared plus 2x minus 2. To solve a quadratic equation, we use the quadratic formula. Substituting 1 for a, 2 for b, and -2 for c, we get -2 plus or minus square root of 12 over 2. Simplifying the square root of 12 gives 2 root 3. So dividing each term by 2 results in -1 plus or minus square root of 3. Therefore, the roots of the polynomial are -1/3, -1 plus root 3, and -1 minus root 3. This confirms that the cubic polynomial has 3 roots.